Welcome everyone. Today I will discuss an important topic of calculus. Topic is continuity and differentiability from graph. So this is most interesting topic. So to know it, we have some basic concept. So look at the basic concept. So look in figure 1, AB is a car. AB is a car. AB is a car. Look, it can be drawn. AB, it can be drawn without lifting the pen. That is, it has no break point. So it is continuous graph. Now in figure 2, the curve AB. So look, it has break point at C. It cannot be drawn without lifting the pen. So A to C, C to B. So it is not continuous at the point C. So other than C, it is obviously continuous. Now, so if a curve can be sketched without lifting the pen, we say that it is continuous. Now, differentiability. What is differentiability? So, we know differentiability. So, this is a car. So, try to recall PT is tangent. So, add xy dy by dx equals to tan psi. We know it. So slope of tangent equals to dy by dx. So dy by dx represents slope of tangent. So a function is said to be differentiable at P if it has unique tangent. Unique tangent. Look for the curve AB. So at the point P, it has unique tangent. So a function is said to be differentiable at a point if it has unique tangent. That is, the curve is smooth. But look in figure 3. So this is well-known graph. All of you know it. This is y equals to mod x. Y equals to mod x. Look, it can be sketched without lifting the pen. So it is continuous. But look, at origin, at x equals to 0. So look, you cannot draw unique tangent at x equals to 0. It has, look, sharp end. So this type, sharp end at x equals to 0. It has corner point. It has king. We can say king, not K-I-N-K, king. Not smooth at the point A. So if we get this type of figure, not sharp, it has sharp edge at O. Look at x equals to A for this figure, sharp edge for this type of figure, then we say it is, look, you cannot draw unique tangent. So the function is not differentiable at that point. So if it is not smooth, it has sharp edge. So, what is our theory, geometrical theory? If it has a sharp edge or king, K-I-N-K, king, that is not smooth or corner point, then it is not differentiable at that point. That is, you cannot draw unique tangent at that point for these curves. So, figure 3, this one and this one. So, this is our basic concept. So, if a curve can be drawn without lifting the pen, then it is continuous. If we draw unique tangent at a point of a curve, then it is differentiable. If a curve has sharp edge or king or corner point, then it is not differentiable at that point. So, this is our basic concept. Now, I will solve some interesting problems. Now, we consider two problems. So, to discuss continuity and differentiability from graph, we should know graph of function. How to draw graph of function. So, problem number 1. So, fx equals to minimum of x comma x square. Minimum of x comma x square. So, one is graph is y equals to x, another is y equals to x square. So, we first find point of intersection of these two curves. So, x square equals to x. So, x into x minus 1, 0. So, x equals to 0 and 1. This is our point of intersection. Now, we draw the graph of y equals to x. So, y equals to x, you know. So, what is intersecting point? So, we are drawing. So, this is x equals to 1 at dotted point. So, y equals to x. So, at x equals to 0, y equals to 0, at x equals to 1, y equals to 1. You know y equals to x is a straight line passing through origin and bisecting axis. This is y equals to x. Now, y equals to x square. So, it is also simple curve. It is parabola. It is parabola. What is the nature of the parabola? Y equals to x, y equals to x square. X square equals to y. That is this type of parabola. This is the nature. Open at the top. So, at x equals to 0, y equals to 0. At x equals to 1, y equals to 1. At x equals to minus 1, y equals to 1. Minus 1 is whole square. So, all of you know this is the curve is parabola. So, this is y equals to x square. So, this is graph of two functions, y equals to x, y equals to x square. Now, look, y equals to fx equals to minimum of x minus x square. So, this is y equals to x, this is y equals to x square. So, we need minimum. So, minimum means this is maximum, this one is minimum. So, look, this part you get this part. You get this part. This part is cancel out. Actually, this one is cancel out. Because, so we are taking minimum. Now, from 0 to 1, so this is y equals to x and this is y equals to x square. So, this one is minimum. This one. So, we take this. We take this part. So, this part is absent. And then from this is y equals to x, this is y equals to x square. So, this is y equals to x and this is, so minimum is y equals to x. So, this part. So, what is the minimum of x minus x square? So, you look, this part is absent. this part is absent. So we are getting y equals to x. At x equals to 0, this y equals to x is absent. This is y equals to x square. Then y equals to x because it is minimum. Y equals to x. So we are getting this curve. Look, it has no break point at any point. So it is continuous throughout its domain. So it is continuous curve. Now regarding differentiability, you look. At x equals to 0, look, what is the at x equals to 0? If you draw the section, so 0. So this one, y equals to x, then this part. So it has a look, it has a sharp edge at x equals to 0. And it has a sharp edge at x equals to 1. This type, then this type. Corner point, that is sharp edge. So it is not differentiable at x equals to 0 and 1. Other than 0 and 1, it is continuous. So look, if we take y equals to x, this point, unit tangent, it is coincides with y equals to x. So final graph is this one. And at x equals to 0, it has a sharp edge. At x equals to 1, it has a sharp edge. So not differentiable. So final conclusion is it is continuous but not differentiable at 0 and 1. Now second one. So we need basic idea of graph of function. Now fx equals to maximum of x comma x cube. So x comma x cube. So y equals to x, y equals to x cube. So we find point of intersection of graphs. So we are noticing that 0, 1 and minus 1. So 3 points of intersection. Now we try to draw the graph of function. So y equals to x first. So what are the point of intersection? So look. So this is x equals to 1. This is x equals to 0. This is x equals to minus 1. Now y equals to x. So we have already drawn this one. It is a straight line passing through origin and bisecting it. Bisecting first quadrant. 45 degree angles. Now y equals to x cube. So y equals to x cube. At x equals to 0, it is 0. At x equals to 1, it is 1. At x equals to minus 1, it is minus 1. Then from 0 to 1, so 0 to 1. So at x equals to 0, it is 0. At x equals to 1, it is 1. So in 0 to 1, it will be below y equals to x. Because if its value lies between 0 to 1, then x cube is always less than 1. But for greater than 1, it is increasing in nature. So roughly we are getting this type of graph. This is at x equals to minus 1, it is at x equals to minus 1, it is minus 1. So this is y equals to x cube. This is y equals to x. So now maximum of x comma x cube, maximum of x comma x cube. Now look, maxima. So this is y equals to x and this is y equals to x cube. So maximum is this one. This is non-minimum. Look, maximum. So we are getting up to this. Now from -1 to 0. So this is y equals to x cube. Y equals to x cube. This part. Now this is y equals to x cube. This is y equals to x. So you have to take maximum. This one is maximum. Now y equals to x. Y equals to x cube. So we are getting this part. Now what is graph of maximum of this? So this part is absent. This part is absent. This part is absent and this part is absent. Now look, it has no break point. It has no break point. But at x equals to -1, look, at x equals to -1, it has a sharp edge. At x equals to 0, it has a sharp edge. At x equals to 0. At x equals to 1, it has a sharp edge. So it is not differentiable at x equals to 0, 1 and -1. So this is problem of JE. Not differentiable at exactly 3 points. Now we consider problem number 3. Fx equals to minimum 1x x square. So same type of problems. So x equals to 1, x equals to x square and x square equals to 1. Y equals to 1, y equals to x square, y equals to x and y equals to x square. 1x x square. So point of intersection. So point of intersection you first find. Intersection. So 1 and 2. So x equals to 1. 2 and 3. So 0, 1. 1 and 3. Plus minus 1. So 1 is already taken. So point of intersection 1, 0, minus 1. So this is 0. This is 1. This is 1. And this one is minus 1. So look, y equals to 1. Y equals to 1. It is straight line parallel to x-axis. This is y equals to 1. Y equals to x. So at x equals to 1, this is y equals to 1. So we have already done it 2 times. This is y equals to x. This one is y equals to x. And y equals to x square. This is also parabola. At 0, it is 0. At x equals to 1, it is 1. At x equals to minus 1, it is minus 1. So you know this is parabola. This one and this one. This is parabolic nature. Y equals to x square. Y equals to x. Now you take minimum of 1x x square. So this is y equals to x and this is y equals to x square. So what is the minimum value? So this one is minimum. This part is minimum part. So this part is cancel out. This part is cancel out. This part also cancel out. From up to 0, minimum of this is y equals to 1, this is y equals to x square and y equals to x is this. Then this one is y equals to x square, this is y equals to x square, this is y equals to x, this is y equals to 1. So what is the minimum? Minimum part is this one. This one is minimum. So this one is cancel out, this one is also cancel out. Now for the last one, this is y equals to 1, this is y equals to x, this is y equals to x square. So this one is minimum, this one. So this part is cancelled and this part is cancelled out. So we are getting a graph. So it has a corner point at x equals to 0. Corner point at x equals to 1. That is why you are taking this line. And corner point at 0 and 1 only. 0 and 1. So what is your conclusion? It has corner point at 0, surface at x equals to 0 and x equals to 1. So it is not differentiable at x equals to 0 and x equals to 1, but continuous everywhere. So it is not differentiable at 0 and 1. At x equals to minus 1, it is also differentiable. Look, it has no sharp edge. So this is problem number 3. So it is also problem of JEE Main. Now we consider problem number 4. So graph is minus mod x and minus root over 1 minus x square. Now, so to solve this problem, we should know the graph of minus mod x and graph of minus root over 1 minus x square. Now look, minus 1 minus x square. So y square equals to 1 minus x square. So x square plus y square equals to 1. So it is a circle of center 0, 0, radius 1. It is a circle. But here only y is negative part. Y is negative. So negative part of circle is acceptable. So it is a semicircle below x-axis. This is y equals to root over minus of 1 minus x square. So you should know the graph. If it is positive part, then above x-axis, the circle above x-axis. And what is mod x? You know, this is mod x. So y equals to minus mod x. This is y equals to minus mod x. Graph of y equals to minus mod x. So mirror image of y equals to mod x is y equals to minus mod x. So mirror image along x-axis. So this is our working tool. Now, look, if we draw the graph here, look, this one, this y equals to minus mod x, this is minus plus 1 minus. So circle, this is circular part. So circle below x-axis. So this is y, this is x, this is x dashed, y dashed. And you have to take domain from minus 1 to plus 1. So this is minus 1, 0, this is 1, 0. Now maximum of, so this one and this. So maximum value, what is the maximum value? So maximum of this curve and this curve. So maximum is upper part. So this is maximum part. This one. Then graph is this part and this part. So what is the maximum part? So this one. So this part is cancelled out. Then this one, this and the mod. So what is the maximum? This part. So this is graph of y equals to mod x minus mod x, and this is semicircle below this. So maximum is this. Now this part and this part. So this one is maximum. So look at the graph. So you are getting graph like this one and this one. So it has a surface at here and surface at here. So if you solve it, you get the surface. So root over 1 minus x square equals to minus mod x. So this is minus x greater than 0. So 1 minus x square is x square. So 2x square equals to 1, x equals to plus minus 1 by 2. So this is minus 1 by 2. X equals to minus 1 by 2. And this is x equals to plus 1 by 2. So look, it has a surface at x equals to minus 1 by 2, at x equals to 0 and x equals to 1 by 2. So it is continuous but not differentiable at 3 points. What are the points? So x equals to this. So problem was given in this form. It is not differentiable at exactly 2 points, exactly 3 points. So it is not differentiable at exactly 3 points. At exactly 3 points. Now you consider problem number 5. So this is slightly difficult. Look. So y equals to maximum, fx equals to maximum, mod x and x square. X lies between mod x lies between mod x less than 2. So this means minus 2 less than equals to x less than equals to 2. So mod x less than 2. So this is our definition. Now this is mod x less than equals to 4 but greater than equals to 2. This means, look, so mod x less than equals to 4. This implies x lies between minus 1 to plus 4 and mod x greater than equals to 2, this part. This implies x greater than equals to plus 2 and x lesser than equals to minus 2, not lying in the interval. So if we take the common part, so we are getting minus 2 lesser than equals to minus 4 lesser than equals to x lesser than equals to minus 2. Yes. So we should know the idea of equations. Now we draw the graph of function. Now look at the restriction. Add 2 minus 2. This is 1, this is 2. This is 3, this is 4. 1, we are taking a rough figure. So this is 2. dotted line. So this is minus 2, minus 1, 0, 1, 2, 3, 4. This is minus 2. Now look, we first draw the graph in this one, minus 2 to plus 2. So y equals to mod x. At x equals to 1, it is 1. At x minus 1, it is also plus 1. So y equals to mod x. This is 2, 1, 2. This is 2. This is 1, this is 2. A rough sketch only. So minus 2 to plus 2, not above this one. Y equals to x square. So at x equals to 1, it is 1. At x equals to minus 1, it is 1. At x equals to 2, it is 2 square, that is 4. 3, this is 4. This is 3, this is 4. So what will be the parabola? Parabola, so look, this type of parabola. This is this one. And for this part, so y equals to 8 minus 2 into mod x. You look, 8 minus 2 into mod x. So graph is 2 into mod x. 2 into mod x. And at 8, so 8, this is 4. So not possible to draw, this is 4 here, this is 1, this is 2, this one is 4, then 8, so y by 8, so y plus 2 into mod x equals to 8, so y by 8 mod x by 4 equals to 1. This is at 4. So we will get this type of graph for greater than 2 to 4. So actually we are getting, look, minus mod x. So if it is 2, so this one is 2 minus mod x. 2 minus mod x. So this is 0, this is 1, 2. So mod of minus x is this one. So it is at 2. Vertex is at 2. Similarly, it has vertex at 8. So it is not possible to draw here because, so look, you are not getting the picture of this. But if you take it, it passes from 4. So this is y equals to 8 minus 2 into mod x. Similarly, this is minus 4, 2 minus 3 minus 4. You will get a figure like this. Now you see the restriction. In minus 2 to plus 2, so maximum of mod x. So minus 2 to minus 1. So look, what is the maximum here? So this part, we are getting this part. This is maximum. And for this is point of intersection is minus 1. And for this, so this is y equals to x. This is y equals to x square. So this part is absent, this part is absent. Then you are getting this one. This part is absent. And from 2 you are getting this part. Actually this one. This one is x equals to 1. This one x equals to minus 1. Then this is x equals to 2. This one. So only one part. So this one, and for less than minus 4 you are getting this part. So y equals to 8 minus 2 into mod x. So this is the graph, and you look, it is continuous. At x equals to minus 2 it has a sharp point. At x equals to minus 1, so this is parabolic arch and this is straight line. They are different. So x equals to minus 2. This is x equals to minus 1. X equals to 0. This is x equals to 0. It has a sharp edge. X equals to minus 1. It has a sharp edge. And x equals to 2. It has a sharp edge. So function is not differentiable at this point. Minus 2, minus 1, 0, minus 1, 2. 1, 2, 3, 4, 5. Not differentiable at 5 point. So it is not possible for me to show this part. So look, so this is the concept, 2 minus 1. So it has, look, this type of, it has surface at 8, but it is not possible to draw. So if you extend it, it will cut at x equals to 8. So today, through this video, I have solved some interesting problem from graph of function. How to check differentiability from graph of function. So this is most important for competitive exam. So I will consider one more class to show differentiability and continuity from graph. Thank you for today.